Hi, my name is Muhammad Arif bin Yaakob. My ID number is 204692. In this video, I'll be covering fluid features. These are the features that I'm going to be talking about. We'll start off with density. The density is the amount of mass per unit volume of a substance. The unit is kilogram per meter cube. For example, the density of water at 4 degrees Celsius is 1000 kilogram per meter cube. For specific weight, it is the amount of weight per unit volume of a substance. We also know the formula to be as density times gravitational acceleration, rho g. For example, water has a specific weight of 9.79 kN per meter cube. Specific volume is volume of a fluid occupied by a unit mass of a fluid. The formula that we are familiar with is 1 over density, and the specific volume of water is 0.001 meter cube per kilogram. The specific gravity is the ratio of the density of a substance to the density of water, and the unit would be dimensionless. In this example, the specific gravity of carbon is 2.26. So if you were to calculate its density, we can multiply its specific gravity with the density of water. So 2.26 times 1000. For surface tension, the underlying forces responsible are the cohesive forces between liquid molecules. The molecules at the surface bond more strongly to the neighboring molecules on the surface. This forms a surface film and makes it more difficult to move an object to the surface rather than to move it when it is completely submerged. In real world, water strider can walk on water because their weight is small enough not to penetrate the surface. They also seem to know when they break the water surface and adjust their leg movements so that the surface tension remains. The next feature is viscosity. It is a measure of resistance to deformation at a given rate. There are two, dynamic and kinematic viscosity. For dynamic viscosity, we can define it as the measure of fluid's resistance to flow when being exposed to an external force. For kinematic viscosity, we use it to measure the resistive flow under the influence of gravity. So what's the difference between these two? In dynamic viscosity, it is useful for describing the behavior of fluids under stress. Mainly, it is useful to describe non-Newtonian fluids. We observe how viscosity changes with the change in shear velocity. If we rearrange the formula, we will get ratio of shear stress to shear rate. In kinematic viscosity, there is no acting external forces except gravity itself. This is useful to describe Newtonian fluids, and the formula is the ratio of dynamic viscosity to density of that fluid. So what are Newtonian and non-Newtonian fluids? Newtonian fluid is a fluid in which shear stress is directly proportional to shear strain, where for non-Newtonian fluid it is not. There is no linear relationship for non-Newtonian fluid. Changes in shear stress can either increase or decrease the shear strain. For Newtonian fluid, its viscosity remains constant regardless of the amount of shear at constant temperature. And for example, water, gasoline, and alcohol. So this linear relationship between the shear stress and the shear rate is called the Newton's law of viscosity. A Newtonian fluid follows this law and gives a straight line on this graph. So how about non-Newtonian fluids? Pseudoplastic fluids exhibit shear staining properties where the viscosity decreases with the rate of applied shear stress. Examples are paint and ketchup. Dilatant fluids exhibit shear thickening properties. For example, the viscosity increases with the rate of applied shear stress. A good example would be a mixture of cornstarch and water. A Bingham plastic fluid exhibits a yield stress, which means it behaves as a fluid above the yield stress, and below the stress level it behaves like a solid. Examples are toothpaste, mayonnaise, and shaving cream. Bingham pseudoplastic fluids are similar to pseudoplastic fluids, with the exception that they exhibit a yield stress level. The fluid behaves as a pseudoplastic fluid above this yield stress level. So that's the end of it. Thank you for your time, and thank you to Dr. Nadine. See ya.